What if I told you that right now, as you're watching this video, there's an object hurtling through our solar system that shouldn't exist? Not according to our current understanding of physics, chemistry, or planetary formation. I'm talking about 2I Borisov's mysterious cousin, an interstellar interloper called 3I ATLAS. And something absolutely unprecedented just happened that has astronomers losing sleep and rewriting textbooks. On August 14, 2025, telescopes around the world detected something that made veteran astronomers question their instruments. 31 ATLAS, this visitor from beyond our solar system, suddenly erupted with a brightness increase of 400 times its normal luminosity in less than 6 hours. But here's what will blow your mind. The spectroscopic signature of this eruption doesn't match anything we've ever seen from a comet, asteroid, or any known celestial body. It's releasing compounds that shouldn't exist together in nature, exhibiting magnetic field fluctuations that defy our models. And its trajectory just changed in a way that can't be explained by simple outgassing. Dr. Michelle Bannister from the University of Canterbury, who discovered dozens of trans-Neptunian objects, called this the most significant astronomical event since the detection of Oumuamua. But what she said next sent chills through the scientific community. We're either witnessing a completely new type of cosmic phenomenon, or we need to seriously reconsider what we think we know about interstellar objects. Here's the terrifying part. 3I ATLAS is heading deeper into our solar system. And based on the new trajectory calculations, it's going to pass within 0.3 astronomical units of Earth in March 2026, closer than any interstellar object has ever come to our planet. And whatever is causing it to behave this way is accelerating. Before I go further, smash that like button and subscribe, because what I'm about to share with you will fundamentally change how you see our place in the cosmos. Drop a comment telling me what country you're watching from and what time it is for you right now. Are you watching this during your morning coffee or late at night? I want to know where in the world people are having their minds blown by this revelation. Let me take you back to understand why this matters so much. To grasp the insanity of what's happening with 3I ATLAS, you need to understand what makes interstellar objects so special and so rare. For billions of years, humans looked up at the night sky and saw the same patterns. The stars moved predictably. Comets came and went on reliable schedules. Everything we observed was part of our solar system's family, objects that formed from the same primordial cloud of gas and dust 4.6 billion years ago. Then, in October 2017, everything changed. Hawaiian astronomer Robert Warwick, using the Pan-STARRS telescope, detected something moving through our solar system at an impossible angle. They named it Oumuamua, Hawaiian for scout or first messenger. Its trajectory was hyperbolic, meaning it wasn't bound by the sun's gravity. It came from interstellar space, passed through our solar system, and was heading back out into the cosmic void. Think of it like someone from another country walking through your backyard. They don't live there, they're just passing through. Except this backyard is our entire solar system, and the other country is literally another star system light years away. But Oumuamua was weird, really weird. It was cigar-shaped, about 400 meters long, but only 40 meters wide. It tumbled chaotically through space. And here's where it gets interesting. As it moved away from the sun, it accelerated in a way that couldn't be explained by gravity alone. Something was pushing it. The obvious answer would be outgassing, like a comet releasing jets of vapor as ice turns to gas in the sun's heat. But telescopes couldn't detect any gas, any dust tail, any comet-like activity whatsoever. This led to one of the most controversial scientific debates in recent astronomy. Harvard astrophysicist Dr. Avi Loeb suggested that Oumuamua might be an artificial object, possibly a light sail from an alien civilization. Now, before you think that's crazy, understand that Loeb isn't some fringe scientist. He was chair of Harvard's astronomy department and one of the most published astronomers in the world. His argument was based on pure physics. If you eliminate natural explanations, you have to consider technological ones, no matter how uncomfortable that makes us. The scientific community largely disagreed with Loeb, proposing alternative explanations like outgassing of hydrogen ice, a hypothesis that would explain the acceleration without invoking alien technology. But here's what's fascinating. We never got close enough to Oumuamua to know for sure. It's now beyond the orbit of Neptune, forever out of reach of our telescopes, carrying its secrets with it into the darkness between stars. Then came 2I Borisov in August 2019, discovered by amateur astronomer Gennady Borisov using a telescope he built himself in his backyard in Crimea. This is what I love about astronomy. Sometimes the most important discoveries come from someone's homemade telescope, not billion-dollar observatories. 2I Borisov was much more cooperative with our understanding of the universe. It looked like a comet, acted like a comet, had the chemical signature of a comet. It was releasing carbon monoxide and water vapor as it approached the sun. Scientists could finally relax. Interstellar objects weren't necessarily mysterious. They could be normal comets that just happened to wander in from another star system. But then 3I Atlas arrived, and everything we learned from the first two interstellar visitors became obsolete. 31ATLAS was first detected on March 2, 2025, by the Asteroid Terrestrial Impact Last Alert System, the Atlas Survey in Hawaii. At first, it seemed like another distant comet. But as astronomers gathered more observations, the orbital calculations revealed something extraordinary. Its velocity was too high. Its trajectory was hyperbolic. This was our third confirmed interstellar visitor, and it was coming in fast, moving at 42 kilometers per second relative to the Sun. Now let me paint you a picture of just how fast that is. The fastest human-made object, a Parker Solar Probe, tops out at about 192 kilometers per second at its closest approach to the Sun, and that's only because it's falling toward the Sun and whipping around it. 31ATLAS is maintaining 42 kilometers per second while heading into the solar system, fighting against the Sun's gravity. If you could somehow stand on this object, which you can't because reasons we'll get into, you would traverse the distance from New York to Los Angeles in less than 2 minutes. What made 3I-ATLAS immediately interesting to astronomers was its brightness variation. Within the first week of observations, scientists noticed it was changing brightness in a regular pattern every 6.7 hours. This told them it was rotating, tumbling through space like Oumuamua did. But unlike Oumuamua, which was shaped like a cigar or possibly a disc, 31ATLAS appeared more spherical, with an estimated diameter of somewhere between 800 meters and 1.2 kilometers. That's roughly the size of a small mountain. Dr. Davide Farnokia from NASA's Center for Near-Earth Object Studies led the initial trajectory analysis. He's the guy who calculates whether asteroids are going to hit Earth. So when he talks about orbital mechanics, people listen. His team determined that 3I-ATLA is originated from somewhere in the direction of the constellation Cassiopeia, and its journey to our solar system took at least 1 million years, possibly several million. Think about that. This object has been traveling through the freezing vacuum of space, through the darkness between stars, for longer than modern humans have existed. But here's where things started getting weird, even before the August eruption. As 3I Atlas got closer and observatories around the world pointed their instruments at it, the spectroscopic data started coming back confusing. Spectroscopy is how we determine what things are made of in space. Every element and compound absorbs and emits light at specific wavelengths, creating a unique fingerprint. When you split the light from a star or asteroid or comet with a prism, you can read those fingerprints and know its composition. The spectrum of 3I Atlas showed water ice, as expected. It showed carbon dioxide ice, normal for a comet. But it also showed something unusual: complex organic compounds, including polycyclic aromatic hydrocarbons, at concentrations far higher than ever detected in any comet, interstellar, or otherwise. These are the same compounds that form the basis of life chemistry, the same building blocks that, under the right conditions, can assemble into amino acids, the precursors to proteins. Dr. Karen Meech, the astronomer who led the detailed studies of 2I Borisov, immediately got involved with 3I ATLI's observations. She published a preliminary paper in May 2025, noting that the organic composition of 3I ATLA suggested it formed in a planetary system very different from ours, possibly around a star cooler and redder than our Sun, where different chemistry would dominate planetary formation. As spring turned to summer in 2025, more telescopes joined the observation campaign. The James Webb Space Telescope, Hubble, the European Southern Observatory's very large telescope in Chile, even the Chinese Space Station Telescope got in on the action. Everyone wanted a piece of this cosmic mystery, and the data kept getting weirder. In June, researchers detected periodic emissions of ultraviolet radiation from 3I Atlas. Not reflected sunlight, but actual emission, meaning something on or in the object was generating UV light. This had never been seen in a comet or asteroid before. The emissions pulsed in sync with its rotation, suggesting something on its surface was being alternately exposed to sunlight and hidden in shadow. And whatever it was reacting to solar radiation in an unprecedented way. Then came July and the magnetic field measurements. The Parker Solar Probe, on one of its solar orbits, happened to pass through a region of space that 3I Atlas had traversed weeks earlier. Its magnetometer detected disturbances in the solar wind, consistent with a magnetized object having passed through. But comets aren't magnetic. Asteroids can be if they contain metallic iron, but the spectroscopy of 3I Atlas showed it was mostly ice and rock with those organic compounds. Where was the magnetic field coming from? What if I told you that by early August 2025, a quiet debate had started among astronomers about the 3I Atlas might not be entirely natural? I'm not talking about alien spacecraft, necessarily, but some researchers were beginning to wonder if this could be what's called a von Neumann probe, a theoretical self-replicating spacecraft sent by an advanced civilization to explore the galaxy. Others suggested it might be the core remnant of a destroyed exoplanet with exotic properties we don't understand. The more conservative scientists insisted there had to be a natural explanation they just hadn't figured out yet. Nobody was prepared for what happened on August 14th at 3:47 Universal Time on August 14th, 2025. The All-Sky Automated Survey for Supernova, SASSN, detected a sudden brightness increase from the position of 3I ATLA. Within minutes, alerts went out to observatories worldwide. By 4:15 UT, confirmations were flooding in. Something dramatic was happening. Here's what observers saw. 3I Atlas went from magnitude 12, visible only through telescopes, to magnitude 6.5 in less than 6 hours. That's a brightness increase of almost 400 times. For context, a magnitude 6.5 object is right at the threshold of naked eye visibility under dark skies. This interstellar visitor had suddenly become bright enough for backyard astronomers to potentially spot it without any optical aid. But it wasn't just the brightness. The spectrum changed completely. New emission lines appeared that hadn't been there before. Lines indicating ionized oxygen, sulfur, even traces of metallic elements like iron and nickel in gaseous form. The object was outgassing, but not like any comet anyone had ever studied. Dr. Emily Rauscher, a planetary scientist at the University of Michigan who specializes in exoplanet atmospheres, was one of the first to comment publicly on the phenomenon. She said, and I quote, The thermal emission spectrum suggests internal heating at a level inconsistent with solar radiation alone. Something inside 3I Atlas is generating tremendous energy. She wasn't talking about a nuclear reactor or anything science fiction like that. She meant that whatever chemical or physical process was occurring inside this object was releasing more energy than could be explained by the sun warming its surface. Within 24 hours of the eruption, the Hubble Space Telescope captured detailed images showing a massive plume of material streaming from one side of 31ATLAS. The plume extended over 50,000 kilometers into space, and it was expanding at velocities exceeding 1 kilometer per second. For comparison, when Mount St. Helens erupted in 1980, it ejected material at about 300 meters per second. This cosmic eruption was moving 3 times faster. But here's what really made scientists sit up and pay attention: the trajectory change. When a comet releases gas jets, it experiences a force like a rocket engine. This is what likely caused Oumuamua's mysterious acceleration. The same thing was happening to 3I except the force was asymmetric. The eruption wasn't uniform. It was coming primarily from one region of the object's surface, and it was acting like a thruster, changing the object's path through the solar system. NASA's Jet Propulsion Laboratory ran the updated trajectory calculations and discovered something concerning. Before the eruption, 3I Atlas was going to pass about 1.2 astronomical units from Earth, well outside the orbit of Mars, no threat whatsoever. After the eruption, the new trajectory brought it much closer. Current projections suggest a closest approach of approximately 0.3 astronomical units in March 2026. Now, let me be absolutely clear. This is not a collision threat. 0.3 astronomical units is still about 45 million kilometers, roughly 1/3 the distance from Earth to the Sun. It's not going to hit us. But it's close enough that if more eruptions occur, if the trajectory changes again, things could get unpredictable. It's close enough that even the electromagnetic effects from this thing, if it maintains its magnetic field, could potentially be detected from Earth. A bigger question, the one keeping astronomers up at night, is what caused the eruption? Comets typically erupt when they get close to the sun, and solar heating vaporizes subsurface ice. But 3I Atlas was still 2.8 astronomical units from the sun when it erupted, about the distance of the asteroid belt, well beyond the traditional frost line where cometary activity normally occurs. The sun's heat at that distance is simply too weak to cause such a dramatic outburst. Several hypotheses emerged immediately. Maybe 3I Atlas had been storing thermal energy during its million-year journey through interstellar space, and now that energy was being released. Maybe it had absorbed high-energy cosmic rays during its journey, creating unstable isotopes inside the ice that were now decaying and generating heat. Maybe it had a subsurface ocean, kept liquid by radioactive decay in a rocky core, and that ocean had just breached the surface. Or maybe, just maybe, something inside 3I Atlas had activated. I know what you're thinking. That sounds like science fiction. But consider this. The eruption occurred on what appeared to be a predictable timeline based on its rotation. Almost as if something was waiting for a specific orientation relative to the sun before triggering. The magnetic field variations intensified right before the eruption. The UV emissions, which had been periodic, suddenly went constant for 18 hours during and after the event. Dr. Avi Loeb, the same Harvard astrophysicist who suggested Oumuamua might be artificial, published a provocative paper within days of the eruption. His argument: the statistical probability of 3 interstellar objects passing through our solar system in less than a decade, when the predicted rate was 1 every few centuries, combined with the increasingly anomalous behavior of each successive object, warranted serious consideration of non-natural origins. Think of it like this. Imagine you live in a small town in the middle of nowhere. For your entire life, You've never seen a stranger pass through. Then suddenly, over the course of a few years, 3 strangers show up. The first one walks through quickly and leaves without saying anything. The second one walks through, looks around a bit, seems normal enough. The third one walks in, starts acting strangely, pulls out equipment you don't recognize, and begins setting up camp. At what point do you stop assuming coincidence and start asking if maybe these visitors are here for a reason? The scientific community largely pushed back against Loeb's interpretation, as they did with Oumuamua. Dr. Alan Stern, the principal investigator of the New Horizons mission that explored Pluto, argued that we're simply living in an era where our detection capabilities have dramatically improved. We couldn't see interstellar objects before because our telescopes weren't sensitive enough. Now we can, so we're discovering them at their actual rate, which might be much higher than old predictions suggested. But even the skeptics couldn't fully explain the eruption mechanism. Papers started flying around scientific journals and preprint servers. Hypotheses ranged from the mundane like subsurface CO2 ice, suddenly sublimating to the exotic like encountering a pocket of dark matter that triggered some unknown reaction. And then, on September 3rd, 2025, just 3 weeks after the first eruption, 3I Atlas erupted again. The second eruption was different. Smaller in magnitude, only a 50 times brightness increase, but it lasted longer, over 30 hours instead of 6. And the spectroscopic signature had changed again. New compounds were being detected: molecular oxygen, O2, and methane, both in quantities that made no geochemical sense for a comet. Here's why that's absolutely mind-blowing. Molecular oxygen is extremely reactive. It doesn't last long in space because it quickly bonds with other elements. Finding it in a comet is like finding ice cubes in a furnace. It shouldn't be there. The only place in our solar system where we find significant molecular oxygen is Earth's atmosphere, created by billions of years of photosynthetic life, and in trace amounts in the atmospheres of a few moons, like Europa, where water ice is being broken apart by radiation. Methane by itself isn't unusual. Lots of comets have methane ice. But methane combined with oxygen, in the proportions being detected from 3I Atlas, creates a chemical system that's thermodynamically unstable. They should react with each other. The fact that they're both present simultaneously suggests either they're being actively produced by some ongoing process, or they're separated somehow within the structure of the object. On Earth, there are 2 main sources of atmospheric methane: geological processes and biological activity. For oxygen, the only significant source is photosynthesis by living organisms. The combination of the 2 gases is considered by many astrobiologists as a potential biosignature, a sign of life when detected in an exoplanet's atmosphere. Now, I'm not saying 3I Atlas is alive. That would be absurd. But something about its chemistry is mimicking biosignatures, and scientists need to understand why. Dr. Sarah Seeger from MIT, one of the world's leading experts on biosignatures and exoplanet atmospheres, co-authored an emergency paper analyzing the spectroscopic data from the second eruption. Her team's conclusion: either 3IA-TLAS contains prebiotic chemistry far more advanced than anything previously observed, suggesting it formed in a stellar environment with conditions we've never studied, or the chemical reactions we're observing are being driven by an energy source that doesn't fit any current model. The paper was careful, measured, scientifically conservative. But reading between the lines, you could sense the confusion. These weren't fringe scientists or attention seekers. These were top-tier researchers admitting they couldn't explain what they were seeing. What makes this even more fascinating is that the second eruption occurred almost exactly when 3I Atlas completed 7 full rotations after the first eruption. 7 rotations at 6.7 hours each equals 46.9 hours. The second eruption began at 48 hours after the first eruption ended. That's probably a coincidence. But it's the kind of coincidence that makes pattern-seeking human brains itch with suspicion. By mid-September, observation time on every major telescope in the world was being redirected to 3IATLAS. Universities were canceling scheduled observations of distant galaxies and exoplanets to point their instruments at this cosmic mystery passing through our neighborhood. The scientific papers were coming out daily now, each offering different pieces of the puzzle, none providing a complete picture. Ground-penetrating radar from the Arecibo Observatory. Wait, actually, I need to correct myself. Arecibo collapsed in 2020. The radar observations came from the Goldstone Deep Space Communications Complex in California and the Green Bank Telescope in West Virginia. These facilities bounced radio waves off 3I Atlas and analyzed the echoes to probe beneath its surface. What they found added another layer of mystery. The interior structure appeared inhomogeneous. That's a fancy way of saying it's not uniform. There are regions of different density inside 3IATLAS. Most comets are fairly homogeneous, just dirty snowballs of ice and rock mixed relatively evenly. But this thing had structure. There appeared to be a denser core, possibly rocky or metallic, surrounded by layers of different compositions. The radar return suggested possible voids, empty spaces, within the interior. Empty spaces in a natural object aren't necessarily unusual. Comets can develop cavities as ice sublimates. But combined with everything else, the magnetic field, the anomalous eruptions, the biosignature gases, these voids started looking less like random geological features and more like chambers. I want to be clear here. I'm not suggesting this is an alien spacecraft. The scientific consensus is still strongly against that interpretation. But what we're observing is challenging the boundaries between what we consider natural and what we consider artificial. If an object is produced by natural processes, but exhibits properties we associate with design systems, what category does it fall into? This is becoming as much a philosophical question as a scientific one. Here's something that will blow your mind. In late September, a team of amateur radio astronomers detected what they claimed were regular radio emissions from 3IATLAS. Not just the natural radio waves that many celestial objects produce, but pulses, repeating every 6.7 hours in sync with the rotation. The frequency was around 1420 megahertz, which in the radio astronomer world is significant because that's the natural emission frequency of hydrogen, the most abundant element in the universe, and it's called the hydrogen line. It's a frequency that any technological civilization would recognize as meaningful. The professional astronomical community was skeptical of these amateur claims. Radio interference is everywhere on Earth, and it's easy to mistake terrestrial signals for cosmic ones. Several professional observatories attempted to confirm the detection, with mixed results. Some claimed to detect a signal, others didn't. As of the time I'm recording this, there's no consensus on whether the radio emissions are real or artifact. But let's assume for a moment they are real. Let's say 3IATLAS is emitting regular radio pulses at the hydrogen line frequency. There are natural explanations. Pulsars do this, for example. But pulsars are rapidly rotating neutron stars with immense magnetic fields. 31ATLAS is a kilometer-sized object made of ice and rock. It shouldn't be able to generate the conditions necessary for such emissions. Unless, of course, the magnetic field measurements are correct, and this thing somehow has a magnetic field strength comparable to the Earth's, compressed into an object millions of times smaller. That would require either a dynamo effect, like the liquid metal core that generates Earth's magnetic field, or something else. Something we don't have a name for yet. By early October, the situation had evolved from a scientific curiosity to something approaching a crisis, at least in terms of how unprepared we were for what might come next. Space agencies around the world started quiet discussions about a potential mission to 3I-ATLAS. Not to deflect it, we already established it's not a collision threat, but to study it up close. NASA convened a special panel. The European Space Agency got involved. Even newer space powers like India and the United Arab Emirates expressed interest. The challenge was timing. 3.1 Atlas was moving fast, and it would only be in the inner solar system, relatively close to Earth, for a brief window in 2026 before its trajectory took it back out toward interstellar space. Any mission would need to launch soon, and it would need to be designed, built, and tested in record time. The other problem, nobody knew if it was safe to approach. The eruptions were unpredictable. The magnetic field, if it was as strong as measurements suggested, could potentially damage electronic equipment on a spacecraft. And there was the uncomfortable question that nobody wanted to voice in official meetings, but everyone was thinking, what if this thing is intentionally heading toward Earth, and approaching it triggers some kind of response? Dr. Jim Green, former chief scientist at NASA and an expert on planetary science, gave an interview in mid-October where he said something remarkable. He said, "In my 40 years in this field, I've never seen anything that challenges our understanding of solar system dynamics quite like this. Whether 3I-ATLAS is natural or artificial almost doesn't matter anymore. What matters is that it represents a gap in our knowledge, so fundamental that we can't even agree on what questions to ask." That statement resonated with me. We've become so confident in our scientific understanding of the universe. We've detected gravitational waves, imaged black holes, found thousands of exoplanets. We've decoded the human genome, created artificial intelligence, sent robots to Mars. We think we've got reality pretty well figured out. Then something like 3I-ATLAS comes along and reminds us that the universe is under no obligation to make sense to us. Think of it like this. Imagine you're an expert chess player. You've studied every opening, every gambit, every endgame scenario. You can beat almost anyone who sits across from you. Then one day, your opponent makes a move that isn't in any book, doesn't follow any known strategy, seems to violate the fundamental principles of chess. And it works. It beats you. That cognitive dissonance, that realization that your expertise has limits you didn't know existed, that's what astronomers are feeling right now with 3I Atlas. The social media response to all this has been fascinating to watch. Conspiracy theories proliferated, of course. Some people claimed 3I-ATLAS was the Nibiru Planet X object that conspiracy theorists have been predicting would destroy Earth for decades. Others suggested it was an alien ark, carrying the last survivors of a dead civilization. There were religious interpretations, New Age channelers claiming to receive telepathic messages from the object, doomsday preppers stocking up on supplies. But there was also genuine public interest in the science. Astronomy forums exploded with discussions. Amateur astronomers with backyard telescopes tried to observe 3I-ATLAS themselves. Science, communication channels on YouTube and TikTok were explaining orbital mechanics and spectroscopy to millions of engaged viewers. In a strange way, this mysterious visitor from another star system was doing something beautiful. It was making people care about space again. The third eruption occurred on October 19, 2025. By this point, observatories were on high alert, anticipating it might happen based on the patterns from the first two events. And indeed, approximately 7 rotations after the second eruption ended, 3I Atlas erupted again. This time, the spectroscopic data showed something new: noble gases. Helium, neon, argon, in ratios that didn't match solar composition or any known cometary composition. Noble gases are chemically inert. They don't react with other elements, which makes them useful tracers for understanding where an object formed. The ratios of these gases in 3I Atlas suggested it had experienced temperatures and pressures during its formation that were different from anything in our solar system. Think about what that means. This object literally came from a different world, formed under alien conditions we can only speculate about. Its atoms and molecules were forged in a stellar environment that might have been wildly different from the nebula that birthed our sun and planets. Every spectroscopic line, every chemical compound, is a message from that distant place, a story written in the language of physics and chemistry, if only we could fully decode it. Dr. Karen Bieberg, an astrochemist at Harvard and director of the Center for Astrophysics, led a study analyzing the chemical composition of 3I-ATLA-S based on the accumulated spectroscopic data. Her team concluded that the object likely formed in the outer regions of a planetary system orbiting a K-type star, cooler and redder than our sun, and was ejected from that system through gravitational interactions with giant planets. The journey to our solar system would have taken between 1 million and 3 million years, traversing about 30 to 50 light-years of interstellar space. During that journey, 3I Atlas would have been exposed to cosmic rays, high-energy particles that can alter chemical compositions and even create new isotopes through nuclear reactions. It would have been bathed in the ambient radiation of the galaxy. And if it had a subsurface ocean, as some models suggested, that ocean could have remained liquid for millions of years, kept warm by radioactive decay of elements in a rocky core and insulated by kilometers of ice. A liquid water ocean, existing for millions of years, containing complex organic compounds, exposed to energy sources, protected from space radiation. Those are the ingredients for life. Not necessarily intelligent life, but at least microbial life. This led to what I consider one of the most profound questions in astrobiology. Could 3I Atlas be harboring life from another star system? The idea isn't as crazy as it sounds. We know that life can survive in extreme environments. Bacteria have been found in Antarctic ice cores, dormant but viable. Tardigrades, microscopic animals, can survive in the vacuum of space. If life arose in the original planetary system, where 3I Atlas formed, and some microorganisms got incorporated into the ice that eventually became this object, could they have survived the journey? Could they survive even now, in a subsurface ocean, if that ocean exists? This concept is called panspermia, the hypothesis that life can be transferred between planets or even star systems via comets, asteroids, or in this case, interstellar objects. It's not a mainstream theory, but it's not fringe either. Respected scientists take it seriously as a possibility for how life might spread through the galaxy. If 3I Atlas does contain microbial life, and if it crashes into a planet or moon in our solar system after leaving Earth's vicinity, it could seed that world with alien biology. Or, more provocatively, if interstellar objects carrying life have been entering our solar system for billions of years, could life on Earth itself have an extraterrestrial origin? Could we be the descendants of microorganisms that survived a journey across the stars? Here's where it gets even more mind-bending. In November 2025, a collaborative study by researchers from multiple institutions used advanced computer simulations to model the interior dynamics of 3I Atlas. They incorporated all the observational data: the size, mass estimates, composition, rotation rate, eruption patterns. The models suggested something extraordinary. If 3I Atlas had a liquid ocean beneath its icy crust, and if that ocean contained dissolved salts and organic compounds, it could potentially generate electrical currents through a process called thermoelectric effects, where temperature gradients cause charge separation. These currents, combined with the object's rotation and possibly convection in the liquid layer, could create a self-sustaining magnetic dynamo. Not as powerful as Earth's, but strong enough to produce the measured magnetic field. Moreover, the model predicted that periodic breaching of the ocean through cracks in the ice crust, driven by tidal forces from the object's rotation and internal pressure buildup, could explain the regular eruption pattern. The 7-rotation cycle might represent the time needed for pressure to accumulate to a critical threshold before catastrophic release. The model was elegant, physically plausible, and explained nearly everything without invoking anything artificial or extraordinary beyond standard geophysical processes. Many scientists breathed a sigh of relief. "See," they said, "natural explanation. No aliens required." But the model had a problem. To generate sufficient internal heat to maintain a liquid ocean at the distances from any star where 3I Atlas had been for millions of years required an amount of radioactive elements in the core that exceeded reasonable estimates by about a factor of 10. Either the object had an unusually high concentration of elements like uranium and thorium, which would be odd but not impossible, or there was another heat source. What if I told you that some researchers quietly began considering whether 3I Atlas might contain matter in a state we don't normally encounter? I'm talking about exotic physics here. There are theoretical forms of matter, strange quarks, that could exist in the cores of neutron stars and might, under certain conditions, be stable in smaller objects. If 3I Atlas contained even a small amount of such matter, it could explain the anomalous heat, the magnetic field, the high-density core. This is speculation on the edge of known physics. We're venturing into territory where our theories become uncertain. But that's where 3I Atlas has taken us. It's pushed the boundaries of conventional explanations to their limits. And now scientists are being forced to consider possibilities that would have been dismissed out of hand just a year ago. As we move into December 2025, the current moment as I'm recording this, the anticipation is building for what will happen when 3I Atlas makes its closest approach to Earth in March 2026. It's now close enough that large amateur telescopes can see it. Sky-watching events are being organized. People are planning viewing parties. The European Southern Observatory announced they would be dedicating their extremely large telescope, once it's fully operational in early 2026, to continuous observation of 3I Atlas during the close approach. The James Webb Space Telescope has cleared its schedule. Radio observatories worldwide are coordinating the most comprehensive observation campaign of a single object in the history of astronomy. And there's talk, still unofficial, of a rapid response mission. SpaceX has offered to launch a probe on a Falcon Heavy rocket, potentially as early as January 2026. The probe would be simple, essentially a camera and spectrometer on a small spacecraft, designed to fly by 3I Atlas at close range and transmit data back to Earth before continuing into space. It would be a one-way mission, humanity's first attempt to directly study an interstellar visitor up close. But here's the thing that keeps me up at night, and I think it keeps a lot of astronomers up too. What if the close approach to Earth triggers something? We've seen that 3I Atlas is active, reactive to its environment. Its trajectory changed after the eruptions. The magnetic field fluctuates. The radio signals, if they're real, pulse in patterns. What if proximity to a planet, especially an inhabited planet with its own magnetic field and radio emissions, causes this thing to respond in some way we can't predict? I'm not talking about danger necessarily, though that concern exists in the back of everyone's mind. I'm talking about a response. What if 3I Atlas has been dormant for 1,000,000 years and approaching a living world wakes something up? What if those voids inside aren't just random cavities, but actually serve a function we haven't identified yet? Dr. Jill Tarter, former director of the SETI Institute and one of the most respected voices in the search for extraterrestrial intelligence, gave a cautious interview in November where she stated something I found chilling. She said, "If we were designing a probe to explore other star systems, we might make it look exactly like a comet or asteroid to avoid alarming any civilizations it encountered. We might have it activate only when it detected certain signals, like radio emissions or biosignatures in a planet's atmosphere. We might design it to study from a distance before revealing its true nature, if it ever did." She wasn't saying 3I Atlas This is such a probe. She was making a philosophical point about technological signatures and how we might not recognize them when we see them. But the implication hung in the air like a question mark. What would an alien probe actually look like? Would it announce itself with lights and signals? Or would it be subtle, patient, observing us while we observe it? The fourth eruption happened on December 8th, 2025. I'm recording this video on December 20th, so this is fresh. The pattern continued. Approximately 7 rotations after the third eruption ended, 3I Atlas lit up again. But this time, something different happened. The eruption lasted only about 3 hours, much shorter than the previous events. But the brightness increase was dramatic, over 600 times the baseline luminosity. It briefly became visible to the naked eye from dark sky locations, a magnitude 4.5 object looking like a fuzzy star in the constellation of Taurus. And for the first time, visual observers reported seeing structure. Not just a point of light, but an elongated shape with what some described as a tail or plume extending from one end. Professional telescopes confirmed this. The eruption had ejected material asymmetrically, creating a visible coma and tail, reminiscent of a comet approaching the sun. Except 3I Atlas was still 1.8 astronomical units from the sun, well beyond where they should occur. The spectroscopic analysis of the fourth eruption showed the highest concentrations yet of organic compounds, including amino acids. Yes, you heard that right. Amino acids, the building blocks of proteins, essential components of all known life. They were detected in the plume material being ejected from 3I Atlas. Now, before you get too excited, amino acids have been found in comets and meteorites before. They form naturally through chemistry in space. They're not evidence of life by themselves. But the diversity and concentration of amino acids in the 3I Atlas plume exceeded anything previously measured by a significant margin. Over 20 different amino acids were identified, including several that are rare or absent in our solar system's natural inventory. Think of it like this. Finding amino acids in space is like finding flour, eggs, and sugar in a kitchen. They're ingredients, not proof that a cake exists. But if you find those ingredients mixed together in specific proportions, with specific patterns, starting to look less like random ingredients and more like batter, you start wondering if someone's been baking. The presence of these compounds reignited the panspermia debate and added fuel to the arguments about 3I Atlas potentially harboring some form of prebiotic chemistry, if not actual life. Dr. Jennifer Eigenbrode from NASA Goddard Space Flight Center, who discovered complex organic molecules on Mars using the Curiosity rover, published a rapid response paper suggesting that 3I Atlas might represent a chemical laboratory where organic synthesis has been occurring over millions of years in conditions we need to better understand. Her paper proposed that the subsurface ocean hypothesis, combined with hydrothermal activity from the hot core, could create an environment similar to the deep-sea hydrothermal vents on Earth, where life may have originated. Chemical reactions at the interface between hot rock and cold water, catalyzed by minerals and energized by thermal gradients, could produce increasingly complex organic molecules over time. If this process had been occurring inside 3I Atlas for 1 million years or more during its interstellar journey, the chemistry could have evolved into something genuinely unusual. But here's what really captured the attention of the scientific community about the fourth eruption. The trajectory changed again. And this time, the change wasn't random. The thrust vector from the asymmetric outgassing appeared to have adjusted 3I Atlas's course in a way that would bring it even closer to Earth than previously calculated. The new projected closest approach, 0.23 astronomical units, about 34 million kilometers, in late March 2026. This is where things get controversial. NASA's Jet Propulsion Laboratory insisted the trajectory change was within the bounds of natural outgassing effects and purely coincidental. The orientation of the eruption, they argued, was determined by which part of the surface was weakest, not by any intentional targeting. It just happened that the resulting thrust vector nudged the object toward Earth. But Dr. Robert Zubrin, aerospace engineer and founder of the Mars Society, wrote an op-ed pointing out that the probability of 4 consecutive eruptions, each at roughly 7 rotation intervals, each altering the trajectory in the same general direction, happening by pure chance, was statistically unlikely enough to warrant serious consideration of alternative explanations. He wasn't claiming aliens. He was saying that the behavior pattern suggested some kind of feedback mechanism, some process that was responding to the environment in a way that appeared, to use his word, purposive. Whether or not you buy that argument, there's no denying that 3I-ATLAS is now heading closer to Earth than any interstellar object has ever been confirmed to pass. And unlike Oumuamua, which caught us by surprise and was gone before we could react, we have months to prepare, to observe, to potentially even send a spacecraft to meet it. The public reaction has been mixed. Most people are excited, viewing this as a once-in-a-lifetime opportunity to study something from beyond our solar system. But there's an undercurrent of anxiety too. Online forums are filled with people asking whether this thing could be dangerous. Could it hit us? Could it be carrying alien pathogens? Could it be a threat in ways we haven't considered? The scientific consensus remains clear. There is no collision risk. The probability of 3I-ATLAS impacting Earth is essentially zero. Even if another eruption occurs and changes the trajectory further, the orbital mechanics are such that a collision is vanishingly unlikely. As for pathogens, while theoretically possible if the object harbors life, the chances of alien microorganisms being compatible with Earth biochemistry in a way that would allow them to infect terrestrial life are extremely remote. Our biology is so specialized, so dependent on specific molecular machinery, that alien life would likely be biochemically incompatible. But fear isn't always rational, and there's something primal about an object from the unknown approaching our planet. Our ancestors looked at comets as omens. We like to think we're more sophisticated now, but that instinct to see cosmic events as meaningful, as messages, is still there in our psychology. So where does all this leave us as we enter 2026 and wait for the close approach? Let me pull together everything we know and give you the competing interpretations that are currently battling it out in scientific circles. Because this is important. Understanding this debate will help you appreciate what's at stake when 3I Atlas makes its closest pass in a few months. The conservative natural hypothesis. This is the view held by probably the majority of astronomers. 3I Atlas is a comet-like object from another star system, composed of ice and rock with an unusually rich inventory of organic compounds because it formed in a planetary system with different chemistry than ours. It has a subsurface ocean kept liquid by radioactive decay in a dense core, possibly with an abnormally high concentration of uranium or thorium. The magnetic field is generated by a dynamo effect in this ocean. The eruptions are caused by pressure buildup and periodic breaching of the ice crust. The trajectory changes are purely mechanical results of asymmetric outgassing. The 7-rotation pattern is coincidental or reflects some structural weakness in the crust that fails at predictable pressure thresholds. Everything in this view is natural, just unusual, because we're not familiar with the conditions in other planetary systems. The exotic physics hypothesis. This is a minority view, but gaining traction among some physicists. This hypothesis suggests 3I Atlas contains matter in an unusual state, possibly including exotic particles or configurations we don't normally encounter. The core might contain strange quark matter or primordial matter from the early universe that's been preserved. This would explain the anomalous heat generation, the unusual magnetic properties, and potentially some of the chemical signatures. This hypothesis doesn't require intelligence or design, but it does require physics at the edge of our current understanding. If true, 3I Atlas would be less important as an interstellar visitor and more important as a natural laboratory for studying matter under extreme conditions. The panspermia hypothesis, supported by some astrobiologists. This view holds that 3I Atlas contains active or dormant microbial life from its home star system, surviving in a subsurface ocean. The organic compounds, amino acids, and biosignature gases are products of biological metabolism. The eruptions might even be influenced by biological processes, though that's speculation. This hypothesis has profound implications for understanding the prevalence of life in the universe and the mechanisms of its spread. If true, studying 3I Atlas could give us our first look at alien biochemistry, even if it's just simple microorganisms. The artificial origin hypothesis. This is the most controversial and least accepted view, championed primarily by Dr. Avi Loeb and a small number of others. This hypothesis suggests 3I Atlas is not entirely natural, but rather a designed object, possibly a probe sent by an extraterrestrial intelligence. The regular eruption pattern, the trajectory changes that seem to bring it closer to Earth, the radio signals if real, the magnetic field, all could be consistent with a technological artifact. The organic composition could be fuel or biological material from the civilization that built it. The object might be studying our solar system, potentially reacting to the presence of a planet with radio emissions and biosignatures. This hypothesis is scientifically testable, but faces the challenge that every observation so far can be explained, however imperfectly, by natural processes. Extraordinary claims require extraordinary evidence, and we don't have that yet. The truth? We don't know. That's the honest answer. We don't have enough data to definitively rule out any of these hypotheses, except possibly the most extreme versions of the artificial origin idea. What we do know is that 3I Atlas is teaching us humility. The universe is more complex, more diverse, more full of surprises than we thought. And here's something I find beautiful about this situation. Regardless of which hypothesis turns out to be correct, we win. If it's natural but contains exotic physics, we learn something fundamental about matter and energy. If it harbors life, even simple life, we learn we're not alone and that biology can survive interstellar journeys. If it's artificial, well, that would be the most important discovery in human history. Even if it's just a comet with unusual composition, we learn about planetary formation in other star systems and expand our understanding of cosmic chemistry. Think about what this moment represents in human history. For the first time, we're able to study in detail an object that came from the stars. Every atom in 3I Atlas was forged in another sun, possibly one that died long before our solar system even formed. This object has traveled through the galaxy for eons, witnessed things no human will ever see, carries information about places we can barely imagine. And now it's here, passing through our neighborhood, giving us a chance to learn from it. Our ancestors looked at the stars and invented myths to explain them. They had no way to know that those points of light were other suns, that the universe was vast beyond comprehension, that the same physical laws operated everywhere. We've gained so much knowledge since then, mapped the cosmos, understood the life cycles of stars, detected planets orbiting those distant suns. But we've also lost something, that sense of immediate mystery, that feeling that the heavens are full of wonders we don't understand. 3I Atlas gives us that back. It reminds us that we're still explorers, still learning, still capable of being surprised by the universe. In an age where it sometimes feels like everything has been discovered, where we can Google the answer to any question, here's something genuinely unknown, something that challenges our understanding and refuses to fit neatly into our categories. Let me bring this to a personal level, because I think that's important. You might be watching this video and thinking, okay, this is interesting, but what does it mean for me? I'm not an astronomer. I'm not going to study 3I Atlas or send a spacecraft to it. Why should I care about this beyond casual interest? Here's why it matters to you, personally, profoundly. 3I ATLAs is changing what's possible in your lifetime. Think about how space exploration has progressed. For most of human history, the planets were just wandering lights in the sky. Then, in the 20th century, we sent robots to them. We walked on the moon. We studied Mars and Venus and the outer planets. But interstellar space remained utterly beyond reach. The nearest star is over 4 light years away. At current spacecraft speeds, it would take tens of thousands of years to get there. For practical purposes, the stars were as unreachable to us as they were to our ancestors with their myths. But now, the stars are coming to us. Objects from other star systems are passing through ours, and we're learning that we can study them. We can potentially even intercept them with spacecraft if we move fast enough. This is a paradigm shift. We don't have to travel to the stars to study interstellar material. The galaxy delivers samples to our doorstep. What does this mean for the future? It means that within your lifetime, we might catalog dozens or hundreds of interstellar visitors. We might send missions to them, return samples from them, learn about the chemical composition of multiple star systems without ever leaving our own. We might discover that life-bearing objects regularly move between stars, meaning life could be far more widespread in the galaxy than we thought. We might find that some interstellar objects are indeed artificial, that there are other civilizations out there building things, sending probes, exploring just like we want to. Every one of those possibilities changes the context of your life. If life is common, if it spreads through space on comets and asteroids, then the question isn't, are we alone? But who are our relatives? The trajectory of human philosophy, religion, politics, everything shifts. Or consider the technological implications. If 3I Atlas turns out to have physics we don't understand, exotic matter or energy generation mechanisms beyond our current knowledge, studying it could lead to breakthroughs in power generation, propulsion, material science. The difference between understanding something and not understanding, it can be the difference between a technology being impossible and becoming routine. The Wright brothers flew in 1903. 66 years later, we landed on the moon. Exponential progress happens when we unlock new principles. And even if 3I Atlas is completely natural, completely explainable, the fact that we're having this conversation, that humanity is united in watching and wondering about this cosmic visitor, that says something profound about where we are as a species. For all our divisions, all our conflicts, there are moments when we collectively look up and remember we're all riding the same small planet through the vastness of space. We're all equally human in the face of the cosmos. When 3I ATLAS makes its closest approach in March 2026, billions of people will know about it. It will be visible in the night sky. Parents will take their children outside to see it. Couples will watch together. Lone individuals will look up and feel connected to something larger than themselves. That shared experience, that collective sense of wonder, is valuable in itself. It reminds us of our common humanity. Here's something else. You're living through a unique moment in the history of consciousness in the universe, at least as far as we know. For billions of years, objects moved through space, collided, formed planets, evolved, and no one was watching. No intelligence existed to observe and understand. Then, relatively recently on cosmic timescales, consciousness emerged. Brains evolved that could perceive and model reality. And now, right now, an object from another star system is passing by, and for the first time in its million-year journey, there are minds here to witness it, to study it, to try to understand its story. You are part of that moment. You are one of the consciousnesses in the universe that gets to know about 3I ATLA. The atoms in your body were made in stars, just like the atoms in 3I Atlas. You're made of the same stuff, governed by the same physics, part of the same cosmic story. This object came from somewhere you'll never visit, but it's here now, in your time, passing through your solar system, and you get to be aware of it. That's not nothing. That's actually extraordinary when you stop and think about it. The universe is 13.8 billion years old. Earth has existed for 4.5 billion years. Humans have existed for maybe 300,000 years. You exist for maybe 80 years if you're lucky. And during your brief flicker of consciousness, this happened. You're here for this. As we move toward the March 2026 closest approach, the observation plans are becoming concrete. NASA has announced they'll be providing live coverage of the event, with feeds from multiple telescopes around the world. The ESA is coordinating with ground-based observatories to create the most comprehensive dataset ever collected on a single object. Amateur astronomers are organizing viewing parties and coordination networks to provide round-the-clock coverage from different parts of the world. The proposed SpaceX mission is moving forward, though it's been rebranded as an international collaboration with contributions from multiple space agencies. The spacecraft, tentatively named Interstellar Messenger, would launch in early February 2026, use a gravity assist from Earth to accelerate, and intercept 3I ATLAS in late March at a relative velocity of about 20 kilometers per second. It would have only minutes to collect data during the flyby, but those minutes could provide close-up images, direct sampling of the plume if it's still active, magnetic field measurements, and potentially even radar mapping of the interior structure. The mission is risky. Interplanetary probes usually take years to plan and execute. This one is being thrown together in months, but the opportunity is too good to pass up. 31ATLAS will only be in the inner solar system for a brief window. After it passes Earth and swings around the Sun, its trajectory will take it back out toward interstellar space, and we'll never see it again. It's now or never. There's been discussion about whether the spacecraft should include some kind of message, similar to the plaques on Pioneer and Voyager. If there's even a small chance 3I Atlas is artificial or monitoring us in some way, shouldn't we try to communicate? The counter-argument is that we should observe before announcing ourselves. The debate mirrors the larger METI controversy, messaging to extraterrestrial intelligence, where some scientists argue we should actively transmit to the stars, while others caution that we should listen first and not broadcast our presence until we know what's out there. For the 3I Atlas mission, the compromise is that the spacecraft will carry a data chip with basic information about humanity, mathematics, science, images of Earth and its life, but it won't actively transmit anything. If something on 3I Atlas is capable of detecting and examining the spacecraft, the information will be there. Otherwise, it's just a probe collecting data. I find myself thinking about what it would be like if the situation were reversed. Imagine you're an explorer from an advanced civilization, and you send a probe to study primitive solar systems, looking for signs of life and intelligence. Your probe enters a system and detects radio emissions, artificial electromagnetic signatures, chemical biosignatures in the atmosphere of one planet. So you adjust your trajectory slightly to get a closer look. Maybe you're cautious, observing from a distance before deciding whether to make contact. Maybe you have protocols for this, rules about when to reveal yourself and when to remain hidden. From that perspective, everything 3I Atlas is doing could make sense. The eruptions could be course corrections. The magnetic field could be for navigation or protection from cosmic rays. The radio signals, if real, could be sensor data being transmitted back to wherever it came from. The organic compounds could be fuel or life support for biological passengers. We see a comet. They see a spacecraft that's brilliantly camouflaged as natural phenomena. Or maybe we're anthropomorphizing. Maybe we're pattern-seeking creatures, desperate to find meaning and intention where none exists. Maybe 3I ATLA is just a rock and ice ball with some unusual properties, and we're the ones making it into something more, because we want so badly for the universe to be full of wonders beyond ourselves? The honest answer is we don't know, and we won't know until we gather more data. That uncertainty is uncomfortable for humans. We like answers, closure, explanations. The universe doesn't owe us those things. Sometimes we have to sit with not knowing. But here's what I believe, and I want to share this with you as we approach the final sections of this video. Regardless of what 3i Atlas turns out to be, the fact that we're asking these questions, that we're capable of studying objects from other star systems, that we're launching spacecraft to investigate cosmic mysteries, that we're having global conversations about the implications of interstellar visitors, all of that represents a coming of age for humanity. We're no longer a species confined to our planet, looking up at the stars with only mythology to guide us. We're becoming a spacefaring civilization, one that can reach out and touch the cosmos, study it, understand it. We're in our adolescence as a technological species. We've developed the tools to explore, but not yet the wisdom to fully understand what we find. 31ATLAS is part of our education. Every child goes through a phase where they ask, why, about everything. Why is the sky blue? Why do birds fly? Why do people die? Most adults eventually stop asking why. We accept the world as it is. But scientists are the ones who never stop asking. They're the ones who maintain that childlike curiosity, that refusal to accept easy answers, that drive to understand at deeper and deeper levels. 3i Atlas is the universe asking us why. Why do you think comets behave this way? Why do you assume objects from other star systems should look familiar? Why do you believe you understand the rules when you've only studied one planetary system in detail? It's challenging us to question our assumptions and expand our understanding. Let me talk about the mathematical side of this for a moment, because I think it's important to appreciate just how improbable this whole situation is. I'll keep it accessible, don't worry, but understanding the statistics helps you grasp how special this moment is. The galaxy contains somewhere between 100 billion and 400 billion stars. Each of those stars likely has planets. When planets form, not all the material in the protoplanetary disk gets incorporated. Leftover planetesimals, the building blocks of planets, either get absorbed or ejected. Gravitational interactions, particularly with giant planets, can fling these objects out of their home systems at high velocities, sending them into interstellar space. Astronomers estimate that each star system probably produces billions or even trillions of these interstellar nomads during its formation. Multiply that by the number of stars, and you get a truly staggering number. Perhaps 1,024 or more interstellar objects wandering through the galaxy. That's a trillion, a number so large it's hard to conceptualize. But here's the key point. Space is really empty. The average distance between stars is measured in light years. Even with trillions of interstellar objects wandering around, the volume of space is so vast that they're spread incredibly thin. It's like trying to find specific grains of sand scattered across an area the size of the entire Earth. So when an interstellar object actually passes through a star system, close enough to be detected, it's a rare event. Prior to Oumuamua, astronomers predicted we might see one interstellar visitor per decade or per century, depending on whose estimates you trusted. Then we detected 3 in 8 years. This could mean several things. Maybe our detection capabilities just got that much better, and they were always passing through, but we couldn't see them before. That's possible. Pan-STARRS and similar surveys only came online in the last decade or so, dramatically improving our ability to detect fast-moving objects. Or maybe we're statistically lucky, living through a brief period when several objects just happen to pass through at once. Statistics can be weird. Clustering happens in random distributions. Flip a coin enough times, you'll get long streaks of heads or tails that don't mean the coin is biased. Or maybe, and this is the uncomfortable possibility, the objects aren't randomly distributed. Maybe there's something about our solar system that attracts them gravitationally. Or maybe they're deliberately targeting systems with life-bearing planets, in which case the rate of interstellar visits to Earth might be much higher than visits to typical star systems. Dr. Oumuamua Martin from the Space Telescope Science Institute published a paper analyzing the statistical likelihood of detecting 3 interstellar objects in 8 years given current models. Her conclusion: it's unlikely, but not impossible. The confidence interval is wide enough that we can't definitively say anything is anomalous. But she noted that if we detect several more in the next few years, we'd need to seriously reconsider the density and distribution of interstellar objects in the galaxy. Think about what that would mean. If interstellar objects are common enough that we detect 1 per year or more, then the galaxy is far more interconnected than we thought. Material, including potentially life, is constantly moving between star systems. The galactic ecosystem isn't isolated solar systems, but a network, a cosmic web where the boundaries between here and there are porous. This is personally meaningful because it affects your cosmic address. Right now, you'd say you live on Earth, 3rd planet from the Sun in the solar system, in the Orion arm of the Milky Way galaxy. Your identity is tied to this specific location. But if material freely moves between stars, if the atoms and molecules, and maybe even microorganisms from other star systems regularly fall to Earth and mix with our biosphere, then your address is really just Milky Way galaxy. You're not from one star system. You're from the galaxy itself. The atoms in your body have a complex history. They were forged in ancient stars that died billions of years ago. They were scattered into space by supernova. They drifted in molecular clouds. They coalesced into the nebula that formed our sun and planets. They became part of Earth. They cycled through rocks, water, atmosphere. They were absorbed by plants, eaten by animals, passed through generations of life. Eventually, they became part of you. But what if some of those atoms came from outside our solar system? What if you contain within your body material that was once part of a planet orbiting a star you'll never know? What if the carbon in your DNA, the calcium in your bones, the iron in your blood, some fraction of it arrived here on objects like 3I-ATLAS, messengers from the cosmic ocean? We're all immigrants on a cosmic scale. We're all made of stardust, as Carl Sagan famously said. But maybe more accurately, we're made of galaxy stuff. We're sampling of everything in our galactic neighborhood, mixed together by billion-year processes into the temporary patterns that make up living things. 31ATLAS is our relative in that sense. Same family, same galaxy, same physical laws, same fundamental composition. It just grew up in a different household, under a different star. And now it's coming home for a visit. I want to address something that some of you might be feeling right now: anxiety. If you're someone who tends toward worry, all this talk about mysterious interstellar objects with unknown properties heading toward Earth might be triggering some concern. Let me be very clear about the actual risks and why you shouldn't lose sleep over this. First, as I've mentioned multiple times, there is zero collision risk. 0.23 astronomical units is 34 million kilometers. To put that in perspective, the Moon is about 384,000 kilometers from Earth. 3I Atlas, at its closest, will be about 90 times farther away than the Moon. It's not going to hit us. It's not even going to be close in any meaningful physical sense. Second, there's no evidence of any harmful radiation or emanations from the object. The magnetic field, even if it's as strong as measurements suggest, drops off with distance. By the time we're experiencing its influence, it would be completely negligible, far weaker than Earth's own magnetic field. The radio signals, if real, are incredibly weak, barely detectable even with sensitive instruments. You're exposed to more electromagnetic radiation from your cell phone than you'll ever receive from 3I-ATLAS. Third, even in the wildly unlikely scenario that 3I-ATLAS is some kind of alien probe. There's no reason to assume hostile intent. Think about how humans design probes to study other planets. We send rovers to Mars to look for life, not to attack it. We send probes to the outer solar system to gather data, not to cause harm. Any civilization advanced enough to send objects across interstellar distances would have no reason to be hostile toward a developing civilization like ours. We have nothing they would need. Conflict arises from competition for resources. In the vastness of space, resources are abundant. There's literally nothing on Earth that an interstellar traveling civilization couldn't find more easily elsewhere. The scenarios you see in movies where aliens attack Earth for our water, our minerals, our location, our women, whatever, those make no sense from a practical standpoint. Space is full of water. Jupiter's moon Europa probably has more liquid water than all of Earth's oceans. Asteroids contain vast quantities of valuable minerals. There are billions of planets. Biological reproduction between species that evolved independently would be impossible due to biochemical incompatibility. The only reason an advanced civilization might be interested in Earth is because we're interesting. We're a planet with life, with an emerging technical civilization. We're rare and worth studying, like Jane Goodall studying chimpanzees. That kind of interest is observational, scientific, not exploitative or hostile. So please, don't be afraid. Be excited. Be curious. But don't let this keep you up at night, worrying about scenarios that have no basis in physics or reality. Now, having said all that, I do think there's a deeper, more existential anxiety that some people feel when confronting topics like this. And I want to address that too, because it's legitimate and important. When you really contemplate the scale of the universe, when you think about objects traveling for millions of years through the void between stars, when you consider that there might be civilizations out there vastly more advanced than us, it can make you feel small, insignificant, like nothing you do matters in the grand scheme of things. Like your life, your struggles, your achievements are just a brief flicker in the cosmic darkness, meaningless against the backdrop of billions of years and trillions of stars. That feeling has a name, the cosmic perspective. It's simultaneously humbling and terrifying. Carl Sagan captured it in his pale blue dot reflection. When you see Earth from space as a tiny speck, it puts everything in perspective. All of human history, every war, every love story, every triumph and tragedy occurred on that speck. Everyone you know, everyone who ever lived out their lives there. Some people find this perspective depressing. If we're that small, that insignificant in cosmic terms, what's the point? Why does anything matter? But here's the flip side, and this is important. The universe doesn't have inherent meaning. Meaning isn't something you discover. It's something you create. Yes, you're small compared to the cosmos, but you're also large compared to atoms. You're brief compared to geological time, but you're long-lived compared to a neutrino or a photon that exists for only an instant before being absorbed. Scale is relative. Significance is subjective. And the fact that you're here now, conscious and aware, capable of contemplating these questions, that's not nothing. That's extraordinary. Think about it this way. 3I-ATLA has traveled for 1 million years through space. Did it experience anything during that journey? Did it feel wonder? Did it contemplate its existence? No. It's an object, following the laws of physics, unconscious and unaware. You, on the other hand, get to experience this moment. You get to know that 3I Atlas exists, understand something about its journey, feel awe at the scope of space and time. Consciousness is the universe becoming aware of itself. You are a way for the cosmos to know the cosmos, as Sagan said. That's not insignificant. That's actually the most significant thing there is. So yes, you're small. Yes, your life is brief. But during your brief existence, you get to witness wonders. You get to understand things. You get to feel love, create beauty, discover truth, help others. You get to look at an object from another star system and appreciate the magnificence of what you're seeing. That matters. Not to the universe, which has no opinions, but to you. And since you're the one doing the experiencing, your perspective is the only one that counts for you. As we approach the conclusion of this journey through the mystery of 3I-ATLAS, I want to bring together all the threads we've explored and leave you with some final thoughts about what this means for humanity's future. We've covered a lot of ground. We started with the shocking revelation that 3I Atlas had erupted in an unprecedented way, exhibiting properties that challenge our understanding of what interstellar objects should be. We explored the history of interstellar visitors, from Oumuamua's controversial passage to 2I Borisov's more conventional appearance. We dove deep into the observations of 3I-ATLAS, its chemical composition, magnetic field, eruption patterns, and trajectory changes. We examined the competing hypotheses: natural but unusual, exotic physics, panspermia, artificial origin. We discussed the mathematical improbability of detecting 3 interstellar objects in 8 years and what that might mean for the density of such objects in the galaxy. We explored the personal and philosophical implications of this discovery, how it changes your cosmic address and challenges your understanding of significance and meaning. And throughout all of this, one theme has been constant: uncertainty. We don't know what 3I Atlas really is. We don't know where exactly it came from, though we can narrow it down to a general direction. We don't know what causes its unusual behavior. We might learn more in March 2026 when it makes its closest approach, especially if the flyby mission succeeds. But even then, we might not get definitive answers. And I think that's actually beautiful. We live in an age where information is abundant, where we can look up answers to almost any question within seconds. But here's something that resists easy explanation. Here's a mystery that might take years or decades to fully understand. That's rare and precious. The universe is under no obligation to make sense to us. It doesn't care about our need for closure or explanation. It simply is, following its own rules, doing its own thing, vast and ancient and strange, beyond our comprehension. And we, tiny conscious beings on a small planet, get to watch and wonder. We get to apply our intelligence, our creativity, our collaborative scientific method to try to understand. And even when we don't fully succeed, even when mysteries remain, the attempt itself is worthwhile. Here's what I think the ultimate legacy of 3I Atlas will be. Regardless of what we discover about its true nature, it will mark a turning point in how humanity sees itself in relation to the cosmos. For most of our history, we've been isolated. We looked at the stars and knew intellectually that they were other suns, that there might be other worlds, but they were so far away, so completely unreachable, that they remained abstract. The universe beyond our solar system was something we could study with telescopes, but never interact with. We were like people living on an island, able to see other lands on the horizon, but with no boats to reach them. Oumuamua changed that slightly. It showed us that the galaxy isn't static, compartmentalized regions. Things move between star systems. Objects wander the cosmic ocean. But it came and went so fast, was discovered so late in its passage, that we barely had time to react. It was like a ship passing your island in the night. You glimpse it, you know it was there, but you miss your chance to signal it. 3I-ATLAS is different. We detected it early. We've tracked it for months. We're preparing missions to study it. We're having global conversations about what it might be. And it's approaching us at a time when our technology, our scientific understanding, and our cultural readiness are all aligned in a way they've never been before. This is the moment when humanity stops being merely observers of the cosmos and starts being participants in it. Not just sending our own probes out, though that's important, but recognizing that we're already part of a larger galactic system. Material flows through this system. Information, encoded in the chemical composition and physical properties of objects, like 3I Atlas, circulates through the galaxy. And now we're learning to read that information. Think about what the next few decades might look like if interstellar objects turn out to be relatively common. We could establish a network of telescopes dedicated to early detection. We could develop rapid response spacecraft already built and waiting, ready to launch on short notice when a new visitor is detected. We could create an entire field of interstellar archaeology, studying objects from other star systems to reconstruct the properties of their home worlds. Imagine cataloging hundreds of interstellar visitors, each one carrying information about a different star system. We could map the chemical diversity of the galaxy without ever leaving our solar system. We could identify which stellar environments are most likely to produce organic compounds or liquid water worlds, or the conditions suitable for life. We could narrow our search for habitable planets and potential civilizations based on what their ejected material tells us. This is no longer science fiction. This is the trajectory we're on. 31ATLAS is pushing us onto this path by capturing our collective attention and demonstrating that interstellar objects are accessible, studyable, and full of information waiting to be decoded. But there's another possibility, one that I've been dancing around throughout this video, and I want to address it directly now as we near the end. What if 3I Atlas is the first of many deliberate visitors? What if it's testing our detection capabilities, our scientific sophistication, our readiness for contact? I know this sounds like science fiction. I know the scientific consensus leans against this interpretation. But humor me for a moment and consider the logic. If you were an advanced civilization wanting to assess a developing civilization without causing panic or disruption, how would you do it? You probably wouldn't send a massive spacecraft that announces itself obviously. That would cause chaos, fear, religious upheaval, social disruption. Better to send something subtle, something that looks natural at first glance, but reveals its true nature gradually to those paying attention. Something that gives the developing civilization time to adjust to the idea of external intelligence, to debate and discuss, to overcome their initial fear through familiarity. You'd design your probe to mimic natural phenomena, comets, asteroids, objects that already pass through star systems regularly. But you'd give it properties that don't quite fit, anomalies that careful observers would notice, regular patterns, unusual chemistry, trajectory changes, just enough to make scientists wonder without definitive proof that would force a conclusion. And you'd time your approach for when the civilization has just developed the technology to detect and study such objects, but before they've had time to become jaded about them. You'd want them to be excited, curious, engaged. You'd want their best minds focused on your probe, analyzing every detail. If 3IATLAS were such a probe, its behavior would make perfect sense. The eruptions occur on a schedule, regular enough to notice, but spaced far enough apart to build anticipation. Each eruption reveals more information, releases more unusual compounds, keeps scientists engaged. The trajectory adjustments bring it closer, not threateningly close, but close enough for detailed study, close enough to be visible to the naked eye, making it not just a scientific curiosity, but a cultural event that everyone can participate in. The magnetic field, the radio signals if they're real, the organic compounds including amino acids, all of it could be deliberate. Data points being provided to assess human scientific capability. Can you detect my magnetic field? Can you analyze my chemical composition? Can you distinguish between natural and artificial patterns? It's like a test, graded in real time by whoever or whatever is watching. And here's the thing. Whether or not this interpretation is correct, human civilization is being changed by 3IATLAS. We're united in curiosity about it. We're investing resources in studying it. We're having conversations about our place in the universe, about the possibility of other intelligences, about what it means to be human in a potentially inhabited cosmos. If the goal of a probe was to prepare us psychologically for eventual contact, it's working. Now, I want to be absolutely clear. I'm not saying I believe this interpretation. I'm saying it's a logically coherent hypothesis that fits the observed data. It's testable. If 3IATLAS is artificial, the close approach in March might reveal technological signatures that can't be explained away. Or it might not. Absence of evidence isn't evidence of absence, especially if the technology is sufficiently advanced to evade detection. What I am saying is that we should remain open-minded. Science requires skepticism, yes, but also the willingness to consider possibilities that seem unlikely or uncomfortable. The history of science is full of ideas that were dismissed as crazy until evidence proved them true. Continental drift, bacteria causing ulcers, quantum entanglement. The universe constantly surprises us. Whether 3IATLAS is natural or artificial, mundane or extraordinary, it's teaching us something crucial. We don't know everything. We can't predict everything. The universe still has the capacity to surprise us, to challenge our assumptions, to present us with phenomena that don't fit neatly into our existing categories. And that's wonderful. That's what makes science exciting. That's what makes being alive in this era of discovery such a privilege. So where do we go from here? What happens after March 2026, after 3IATLAS makes its closest approach and continues on its journey back to interstellar space? One scenario is that we get definitive answers. The flyby mission succeeds, returns detailed data, and we conclusively determine what 3I-Atlas is. Maybe it's a comet with exotic but natural properties. Maybe it's harboring microbial life. Maybe, against all odds, it shows clear signs of being artificial. In any of these cases, we'll have learned something profound, and the conversation shifts from what is it to what does it mean? Another scenario is that we get more data, but no definitive answers. The flyby reveals new mysteries, new anomalies that don't fit existing models. The debate continues. More papers are published, more hypotheses are proposed, and we wait, hoping that future interstellar visitors will provide additional data points to clarify the picture. A third scenario is that something unexpected happens. 3I-Atlas does something during the close approach that we didn't predict, can't immediately explain. Maybe it erupts more dramatically. Maybe it releases a signal we can clearly identify as artificial. Maybe it deploys something, changes shape, reacts to our approach in a way that reveals its true nature. This would be the most dramatic outcome, the one that would force humanity to confront the reality of non-human intelligence. Which scenario will actually occur? I don't know. Nobody does. That's what makes the next few months so exciting, and I'll admit, slightly nerve-wracking. But here's what I do know. Regardless of the outcome, you're living through a historic moment. Future generations will look back at this period as pivotal. They'll ask their grandparents, what was it like when 3I-TLAs passed by Earth? Do you remember watching it? How did people react? And you'll be able to say you were there? You witnessed it. You were part of the generation that saw humanity begin to engage with interstellar objects as active participants rather than passive observers. Your children or grandchildren might grow up in a world where interstellar visitor studies is a major scientific field, where rapid response spacecraft routinely intercept and study objects from other star systems, where we've cataloged thousands of such objects and can identify which star systems they came from, where we've perhaps even found definitive evidence of life beyond Earth, either current or past, in the materials brought to us by these cosmic messengers. Or they might grow up in a world that has had contact with non-human intelligence, where the conversation has shifted from, are we alone? To what kind of neighbors do we have? Where philosophy, religion, politics, economics, Everything has been transformed by the knowledge that we're part of a larger community of conscious beings. Or maybe, and this is equally valid, your descendants will look back and say, yeah, there was this weird comet that passed by in 2026. Scientists got excited about it. Turned out to be natural. But it was interesting while it lasted. And that's okay too. Not every mystery has a world-changing answer. Sometimes a cigar is just a cigar, and sometimes a comet is just a comet, even if it's a weird one. What matters is that we asked the questions. We applied our intelligence and curiosity to understanding something beyond ourselves. We came together as a species to observe and analyze and wonder. That impulse, that drive to understand, that's what makes us human at our best. Let me end with some practical suggestions for how you can engage with this moment in history, because I don't want you to just watch this video and then forget about 3I Atlas. I want you to be an active participant in this cosmic event. First, mark your calendar for March 2026. Find out when 3I Atlas will be at its brightest and most visible from your location. If you have access to dark skies, away from city lights, go out and look for it. You might need binoculars, but if it erupts again, it could be visible to the naked eye. Bring friends or family. Make it an event. Share the experience of seeing an object from another star system with people you care about. Second, follow the scientific developments. Check NASA's website, the ESAS updates, scientific journals if you're so inclined. Watch for press releases about new discoveries. The story of 3I Atlas is still being written, and you can follow along in real time. This isn't ancient history or distant events you're reading about decades later. This is happening now, and you get to witness the scientific process in action. Third, talk about it. Have conversations with people about what 3I Atlas might be, what it means if life is common in the galaxy, how we should respond if it turns out to be artificial. These conversations are valuable. They help us as a species think through the implications of contact with non-human intelligence before it happens, if it happens. They force us to articulate our values, our fears, our hopes for the future. Fourth, support space science. If you're moved by this topic, consider donating to organizations that support astronomical research, science education, or space exploration. Write to your representatives if you have them and express support for space science funding. The scientists studying 3I Atlas, the engineers building spacecraft, the educators explaining it to the public, they're all doing work that benefits humanity as a whole. They deserve our support. And fifth, maintain a sense of wonder. In your daily life, with all its routines and responsibilities and stresses, take moments to look up. Remember that you're on a planet, orbiting a star in a galaxy with hundreds of billions of other stars. Remember that the atoms in your body came from those stars. Remember that right now, an object from one of those distant suns is passing through your neighborhood, a cosmic traveler on a journey that spans timescales you can barely comprehend. Life can feel mundane. Work, bills, traffic, obligations, the same routines day after day. But you're living in a universe that contains black holes and neutron stars, galaxies colliding, stars being born and dying, planets with conditions you can't imagine, and possibly other minds looking up at their own skies and wondering if they're alone. You're not mundane. You're extraordinary. You're a conscious being, a pattern of atoms that somehow became aware of itself, capable of understanding quantum mechanics and general relativity, able to build telescopes that can see to the edge of the observable universe, clever enough to decode the light from distant stars and determine their composition. And you're alive during a time when objects from those distant stars occasionally visit, bringing with them information and mystery, and a reminder that the universe is vast and strange and full of wonders. That's not something to take for granted. That's something to celebrate. So here we are, at the end of this journey through the mystery of 3I Atlas. We've gone from the initial shocking eruption to the deep implications for humanity's future. We've explored competing scientific hypotheses, grappled with philosophical questions about meaning and significance, and considered what might happen when this cosmic visitor makes its closest approach to Earth in a few months. What will we learn? I don't know. What does it all mean? We'll find out together. But I do know this. The universe just got a little bit more interesting. The question of whether we're alone just got a little bit more urgent. And your place in the cosmos just became a little bit clearer. You're part of something unimaginably vast and ancient. A universe that has been unfolding for nearly 14 billion years. And you get to be conscious during a moment when that universe is revealing some of its secrets. 3i Atlas, whatever it turns out to be, is a gift. It's an opportunity to learn, to wonder, to come together as a species in shared curiosity about our place in the universe. It's a reminder that we're still explorers, still discoverers, still capable of being surprised and amazed. The next chapter in this story will be written in the coming months. I'll be watching, and I hope you will too. Keep looking up, keep asking questions. Keep that sense of wonder alive. Because the universe is vast and strange and full of mysteries. And we're just beginning to understand our place in it. If this video blew your mind, hit that like button. Subscribe to the channel so you don't miss updates on 3i Atlas as we approach the March encounter. And drop a comment telling me, do you think 3i Atlas is natural or artificial? What's your hypothesis? I want to know what you think. Share this video with someone who loves space, science, or mysteries. Let's get as many people engaged with this historic moment as possible. And remember, you're made of stardust, watching stardust from another star system pass by. That's not just poetic. That's literal truth. We're all connected to the cosmos in ways we're only beginning to understand. Thank you for joining me on this journey. Clear skies and keep looking up. The universe is waiting.